All right, welcome back, math fans in pre-AP, pre-calculus 11. We are now looking at, hey, division of these polynomial rational expressions. So when we're looking at division, here's example 8, and we're going to call that 14 over 35 divided by 77 over 55. Right, so let's just think about how we did this. And we did this by reciprocal. So this is 14 over 35 times 55 over 77. So we could also call this a flip. And what we can do here is now this is just going to become 2 times 7 times 5 times 11. I'm just going to prime factor it so it's easy to see what I have. And this is going to be 7 times 5 times 7 times 11. Okay, 7, 5, 11 cancels out, and I get 2 over 7. Now, I could also done this, simplified it here. This would have been 2 over 5, and this would have been 7 over 5. And then if I did 2 over 5, divide by 7 over 5, I could also say that this 5 goes to the top and this 7 goes here, and I'll get 2 over 5 times 5 over 7. That cancels, and I'll get 2 over 7. Why that method works is so that if I have a over b divided by c over d, that's the same as saying a over b divided by c over d. And that means that the fraction flips, right? And it flips because we're trying to figure out how much something fits into that fraction, c over d, and that's AD over BC. So this is like we're thinking of places, right, that the bottom and top match and the two middles go together, right? So here, the two middles go together, and then the bottom and the top match as well, right? So that's a nice shortcut for division there, that we can see that with proof. And division is always thinking about how many times something goes in, right? Like a nice easy one is, oh, what's 2 divided by 1/2? Well, if we were thinking about 2 divided by 1/2, how many times does a half fit into 2? Well, half plus a half plus a half plus a half is equal to 2. So how many times did it fit in? 1, 2, 3, 4. So this is actually equal to 4, right? So, but the division algorithm means to find that through our algorithm, that'd just be like times 2 over 1, and that's 4. So that's partly why the our reciprocal works when we're dividing fractions there, right? So perfect. Well done. Let's do a couple examples here. Just two, right? So we know that this is just going to be the same as multiplication, but with a bit of a twist. So times x plus 3 divided by x squared plus x minus 2, and that's all over x squared minus 4. Let's go ahead and call this x minus 2 over x plus 3 times, let's keep the division there just for a moment, divided by x plus 2x minus 1, and this is all over x plus 2, x minus 2, like that. So even in this case, what we're going to do is this is going to become the denominator. That's going to go down, and this is going to become the numerator. We take restrictions from all three. So the restrictions here are going to be x cannot equal, well, -3, -2, 1, and 2. -3, -2, 1, and 2, right? Because I cannot take, when this goes to the denominator, I also cannot have 1 because that's going to be on a denominator there. So let's put it all together through multiplication. So this is going to become x minus 2 over x plus 3, right? And we'll just put the things on there. This is x plus 2, x minus 2, and this is going to be x plus 2, x minus 1. All right, now we can do some canceling. the x minus 2. Oh, no. We don't have an x minus 2 to cancel with. Ooh. We do have an x plus 2 that can be simplified out, right? That'll be simplified out. But it looks like we have nothing else there that'll make this happen for us. So this is just going to be x minus 2 squared over x plus 3 and x minus 1. So we're good there. We know what we're doing. Okay, and let's do one more just to finish this off. So we have 2x, and we'll go do the quicker step here. 2x squared plus 3x minus 2 over 2x minus 1 divided by 4 minus x squared. And this is its own thing. So let's change this into 2x. Let's do all the factoring, and we'll make it multiplication at the same time. So it'll be 2x minus 1, and this will be x plus 2. And does that get what we need? Yes, it would. And this will be on the bottom 2x minus 1. And then on the bottom here, this becomes 4 minus, this is 4 minus x squared. But that's a difference of squares, so I'll get 2 minus x. And then 2 plus x, like that. Right, so that's that difference of squares, right? This is that piece there. That's going to be 2 minus x, 2 plus x. Well, good news, math fans. I know right away. Well, before we get to the good news, let's get the NPVs here. The NPVs are going to be x cannot equal a half, negative 2, and 2. So I'm going to say it can't be plus or minus 2, and it can't be 1/2. Those are the non-permissible values. Right, the half comes from plus 1 divided by 2. Here, that gets canceled, that simplifies out. This simplifies out, that simplifies out. And we are good. We just have 1 over 2 minus x. That is it. We are good. We are golden, math fans. All right, so that's lessons 1 and 2. I'll get lesson 3 up quick as I can, and we'll keep moving on that. Thank you, math fans, and keep rocking, keep doing your math.